This is basically just a graph application. It's very primitive, it doesn't do much, but here I am. So there's a couple different coordinate spaces, and this is useful if you're trying to manipulate things in a 2D space. If you had like some sort of vector graphics program, perhaps, or any kind of image manipulation program, you might find yourself coding something like this. So, all right, so let's start with these coordinate spaces. So I call this first one Cartesian normal. And basically, 0, 0 is in the center here. And as you go up, you get to 1 here, and then -1 at the bottom. And so I've labeled these for you. And having these labels is really useful when you're trying to troubleshoot things. You may not, of course, show this to the user. This is just kind of, it's a code example. It can help you debug and make sense of these coordinate spaces. And when I was trying to troubleshoot writing imaging app type of code, I found it pretty nice to make something like this kind of a base class for any sort of canvas. So that way, if there is any issues with the coordinate spaces, or perhaps items being manipulated are not matching where the mouse cursor is, you can like turn on the visibility of this base class, and you can kind of check your numbers in your different spaces. So that's kind of the utility of a class like this. This little square thing doesn't do anything yet. We can cover that in a second. So Cartesian normal space has 0, 0 in the middle. Cool. So, and then here's Cartesian pixel space. And I'm calling it Cartesian just to be, I think I Googled it, that this is what it's called. But I'm not a mathematician, so I could be using this term incorrectly. But basically, to mean that 0, 0 is in the center. So in pixel space, in graphics, it's really common to have 0, 0 in the top left, and we can cover that in a second. So I'm just saying it's Cartesian space because 0, 0 is in the middle. So this is Cartesian normal space. It goes from -1 to 1, -1 to 1. And this is Cartesian pixel space. And this goes from -1/2 of the width. So like if this is 800 pixels wide, this is -400, this is 0, and this is +400. Then here's pixel space, and then so 0, 0 is right here. So you can see we're going from 0 up to height. So total height is here. This is the normal coordinate space. 0, 0 is at the bottom left here. So 0 to width here, 0 to height here. Like this. If you downloaded some code off of GitHub, it may come in a mathematical coordinate system like this one or this one, and your GUI code, a lot of graphics code, will use something like this or like this, and just being able to see instantly where you are is really handy. And you have to make the GUI code interact, right, with your mathematical libraries. So when you may be making assumptions about coordinates you passed in between the two of them, they may not be true, and this just helps speed up debugging quite a lot. So with any Qt application, you start or with any C++ application, your program entry is going to be in main.cpp. Here's int main. So I made 2 QML types, image.io and tab widget, and then we load main.qml. And QML is kind of a declarative language with some functional areas in it, and I think it's really nice for GUI programming. After I got used to it, I actually found it to be quite nice in many respects. And also very quirky in other respects. So anyway, so here's main.qml. So the first thing that we do is we load main.qml. So there's test, as you can see. The item is called test here. And then here I just define rect_ellipse tool. And then here's menu bar. You can see that this is a built-in property of application window. Like if you just hit F1, I do like that about Qt Creator. If you just hit F1 on the type here, you can see menu bar, it's built-in property. right here, rectellipse tool.qml. This is a overlay base. Yeah, so we have main.qml, and then the first item defined here is this rectellipse tool. And if you go to rectellipse tool, you can see that its base class is overlay base. So this is kind of the way that I've always done inheritance kind of in QML, is to make the top layer, my base class, and then I can make another class that uses that base class as its root item. So like, here's overlay base. When I say overlay, all I'm saying is that I have a transparent rectangle overlaid on top of this. That's what overlay means. And I'm calling it overlay base to say this is a base class. So this ellipse tool has some functions in it. This is for getting a circle. This is for getting a rectellipse, which just means rectangular ellipse. A rectangle has perfectly straight edges, and an ellipse has curvy edges. And if you were to change some mathematical properties, you can oscillate between a ellipse and a rectangle. Here's test get y Cartesian. Okay, I started writing some tests to test my Cartesian coordinate system. Cool. So we call and then we say you passed. Okay, very nice. And so on completed, here I am calling my test code. Here is canvas. So yeah, canvas is this built-in QML type, and a canvas is less declarative and more kind of more like OpenGL. So you have this class on paint that refreshes at the same rate, like 60 frames per second, as your screen does. And on paint just keeps getting called over and over and over, and so this stuff executes. And basically all that's happening here is that rectellipse, that black shape, is getting drawn. So if I were to, for example, comment all that out. You can see that that shape is gone. Cool. And that's probably for another video, maybe more about how this works. Okay, so there's the rectellipse tool. It has a canvas inside of it, and it has this is get rectellipse and root difference. I honestly can't remember what I was going for with these functions. So here's overlay base, and Cartesian to pixel point. Okay, so here's your Cartesian, and it's going to give you your coordinates back in pixel space. Convert. Okay, so this is like a private thing that's called here. Okay, so this is where all the actual coordinate space conversion is happening. So here's some settings. Okay, yeah, this is what I really liked about this class. You're gonna do, your base class, you can just quickly turn on and off the things that you want to look at. So if you want to send a production, for example, you can set show axes to false. Maybe you don't want to see that grid. You can set, you can take the ticks off, tick length. You can change the number of columns so that your ticks, so if we change this to 4, for example, 4 rows and 4 columns. So you can see here that we changed that value, rows and columns, and now there is 1, 2, 3, 4 rows and 1, 2, 3, 4 columns. And see here our pixel space is kind of adjusting and stuff like that. So just lets you switch between these coordinate spaces and see what's going on, adjust some things. And I just find this really a really nice base class for troubleshooting, things that involve mouse interaction, dragging things around on a two-dimensional canvas in Qt applications.